Okay, Lauren, let's see if we can do something for you. Right, so I've looked at your data and I've created a new R project directory. So your data looks like this, if I'm right. Let's view that file. So you got some really nice data, great, and you want to plot columns. I think was it 1, 4, 5, and 6? Let me just check that. Oh, 2, 4, 5, and 7. 2, 4, 5, 7, right? Okay, 2, 4, 5, 7. So I'm assuming you mean 2, 4, 5, and 7, right? Okay, so I'll tell you what, let's do number 7 to begin with, see what happens, right? And I'm assuming you're trying to perform a t-test between the two gender groups, male and female, right? So the first thing I'm going to do, so I can read this file in, is I'm going to just, rather than use the Excel spreadsheet, I'm going to save it as a CSV file, okay? So I'm going to do .csv. That's going to convert it to a comma-separated file. Yes. UTF-8, yes. And, oh, it already exists. Okay, let me just make sure that that's not there. Yeah, I was playing around with it already. Okay, let's do that again. File, save as .csv. Okay. And now in my R project directory, I've got a CSV file. And the reason I've done that is because R has a native function that will read a CSV file, but not an Excel file. I would have to import a module, import a library to do that, and I don't want to have to worry about explaining you how to install an additional package to do that. So we're just going to use the sort of native read.csv command. So let's define a variable. Let me get rid of these a sec. I'm going to clean that up as well. Right, so let's just read that straight into a data frame. Okay, we're using the function read.csv, open brackets, quotation, and the file is 2017, and it's the CSV file. Okay, control and enter on that, and this will pop up, and I've now got all of my data in here like this. Lovely stuff. Okay, so let's take a look. So what I'm going to do now is I'm going to let's just take a look at column 7 first, right? And I'm going to subset that. Let's start a new variable called df2. Okay, and I'm going to do that is df. I'm going to splice it up using this list. So I want the first column, which is the gender. And then number 7, which was one of your data columns. I'm going to do that. And if you look at df2 now, I've just got 2 columns. This is a mouthful, isn't it? So let's rename this column just so we can work with it a bit better. So to do that, I'm just going to go names, df2. I'm going to say that that's going to be the vector gender. And let's just call it var for variable, okay? Run that, and if you look at your df2 now again, I've just got these 2 here. So I want to, well, the first thing we'll do is we'll look at the histogram for the data. That's really easy to do. So not histogram, I meant a box plot. So let's look at your box plot. Okay, I'm going to plot var versus gender, and I'm going to use that data is equal to df2. Okay, now you can see here that isn't great. Something's happened here, and I've got some real big outliers which are probably errors in your spreadsheet. So I would go back and look at your original data and see if they haven't been typed in correctly or not. We can still do something about that. Let's just filter that. So let me just take a look at the y label. Say ylim is equal to c. Let's just do between 0 and 1, right? Okay, so it looks to me like they even allow us. So I'm not going to do anything below. I'm just going to say 0.4, right? So that's going to filter that data so that no value bigger than 0.4 is going to be in here. I mean, I would even argue these might even be mistakes, but you'd have to go and check. That's okay. I mean, it does look like there is a significant difference between the means. If you look at the medians of these, the male one is much lower. So I think we can still use this data. But what I really want to do is I want to filter out those outliers, okay? So to do that, I'm going to do df2 is df2, okay, and I'm going to use the which function to do it, and I'm going to put this condition df2 and the variable column must be less than 0.4, and there has to be a comma there. I'm going to do that. Okay, so I now should look at that column, and there shouldn't be any values greater than 0.4 here. In fact, I would even say anything bigger than 0.2 really, but we won't worry about that now. Okay, so I've got my data, I've filtered it out, and I'm ready, I think, to do a t-test for these. Now, to do the t-test, you're going to use the command t.test, and then you're going to put your male data and your female data, okay? And it's going to compare those two data sets. Now, to extract those two variables, which I'm going to call male and female, let's do the male first. Let's call male, and I'm going to call my data frame, and I'm going to filter it again, which df2, and this time the variable is gender, okay? And I'm going to say equals male, another column there, right? So I've created a new data frame now, which has only got the male data in it, right? And actually, I don't want it as a data frame. I just want it as a list of these variable values here, okay? So I'm just going to put the $VA after that, and if you look now, it's just a list of that data. I can type it out, and it'll run that, and there you are. It's giving me all of the values at the bottom there. Let's do the same for the female. df2 which df2 gender equals female, comma, and I'm going to do that as VAR, and again I'm going to do that. Oh, made a mistake here somewhere. Where is it? Undefined column selected. I need to put that after the parenthesis. There you go. So I've got a column with 19 male values and 34 female values in it, and I'm going to do a t-test between those two now, just by doing t-test male, comma, female. Control and enter on that. P-value of 0.46, so there is a significant difference between the means in those two groups for this variable, okay? I can then run that for any column I want, so just by redoing this entire file, okay? So say I want to do column 1 is always going to stay the same because it's gender. Say I want to do column 2 like you did earlier. I'm just going to make that a 2 and do doop 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 doop, okay? And it's going to give me another p-value, which is much less this time. Actually, sorry, this is changed. And so you can see now the big difference between the male and the female. P-value less than 0.05, so that is significant. I made a mistake, right? So let's go back and do 7. Doop, 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 doop. Okay, p-value of 0.46, much bigger than 0.05. So I would say there's no significant difference between the means in that group. Okay, so don't let me confuse you, right? And you can do the same for what was the other one? Let's do 4 as well. Okay, so you might have to change your filter for some of these. So I think this is a bit naughty. So we probably need to filter for let's do 1 here. It's better. And again, p-value of less than 0.05. So I'd say that was definitely significant. Okay. Right, I hope that's helped. The one thing you need to be really careful of is whether these distributions are actually normal or not. So there's a test called a Shapiro test, Shapiro tests, and if you put male in here, see, now that's a value bigger than 0.01. So I would argue that for this particular column 4, your male data, and that's probably because there's not a lot. There's only 9 male values in there, right? It's difficult for it to be normal, whereas the female is probably fine. Yeah, even then, still sort of bigger than. So for a Shapiro test, it needs to be less than 0.1 really. Let's try a different column. Okay, so the p-value for the column 7 is absolutely fine, and also for the male. Okay, so I would say that's a legitimate test. Okay, I hope that was useful. Why don't you swing by the office at about 12 o'clock tomorrow, and we can talk this through as well. If you can't, don't worry, just drop me a line.